Hello viewers and welcome to this lecture on the history of electronic media, how the electronic media came about slowly. Today we are living in a networked society, which means that if we are equipped with a smartphone, then whichever part of the world our friend or relative is, it's not difficult. In the blink of an eye, we can get in touch with the person and he will never be lost for us as long as his phone is open. Okay? And we will never get lost because all smartphones are equipped with the GPS system. So we have got used to that that's a kind of safety net that is there, and that we will not get lost from each other, and it's thanks to this very advanced electronic media that is there with us in the form of this smartphone. But this has not been the case always, and so for momentarily let us transport ourselves to the deep jungles, dense jungle of Africa by the side of the river Congo, where there is no satellite connectivity, no mobile phone towers, and it's a very primitive situation. So in such a situation, how would you imagine to get in touch with somebody whom you cannot see and who may be about 100 miles away? Is it at all possible? Now an explorer, a European explorer, he has written in his memoirs that when he had first gone to Africa in one of his early African expeditions, sometime in the late 19th century, he was gliding down the river Congo, and there was a young African boy who was his guide, who was also there in the river. Suddenly that boy got up and went to the edge of the boat and cupped his ears. Okay, and then he came back and he told the boatman, please turn the boat, I have to go back to my village, there is an emergency call. So emergency call, the European was totally taken aback. Emergency call means how do you know, and who is calling you? So the boy said, you just strain your ears, you will be able to hear drum beats, and the European did actually pick up the strains of a drum beat. So the boy said, these are talking drums. So that's a very interesting way the Africans communicate with each other, through talking drums. Meaning that when they beat their drums, there is a particular kind of rhythm, and each rhythm is almost like talking, and each rhythm is coded with a particular kind of a message. Okay, and in the deep, quiet jungle of Africa, the drum beat can travel to a few miles, and then it is relayed by the other neighboring villages. It is relayed, and in the matter of an hour, all the villages in the radius of 100 miles know what the message is. So therefore, birth of a boy or death of an old man or somebody's wedding or any other emergency thing can be relayed to all the neighboring villages within a radius of 100 miles through these talking drums. So that is one skill the Africans have mastered in order to remain networked in their own society. And this urge to remain networked has been there in all societies, and different societies in different eras have found ways of sending messages far away, far from where they are. For example, if supposing in a battlefield there is an emergency situation and more soldiers are required, okay, that you are about to storm into a fort and there aren't enough soldiers, more soldiers are required. So what is the easiest and the fastest way in which you will send message to the headquarters? So in a primitive era, the easiest way is through a horse. So a horse, a messenger will ride across on a horse, and he will give the message to the headquarters and send more soldiers. Now in the 12th century BC, as you perhaps know, the war of Troy was fought in Greece, the Trojan War. And the Trojans lost the war, and one particular lady called Clytemnestra, sitting 400 miles away in Mycenae, a small Greek township, Mycenae, Greek state, she came to know the same night that Troy had fell. The war was lost and Troy had fell. So how did she come to know? It was through a signal of fires. And this is written, I'll just read out in a play written by Aeschylus. It's written here. Sent forth his sign, and on, ever on, beacon to beacon sped the courier flame. The blazing signal rose from Mount Ida, carried across the northern Aegean Sea to the island of Lemnos, from there to Mount Athos, so sped from stage to stage, fulfilled in turn flame after flame. That means the message was coded through fire, through flame, and it was relayed from flame to flame, and Clytemnestra got the message sitting in her own kingdom in a small island in Greece. Okay. Now, in India, if you have read Kalidasa's Meghadutam, Kalidasa had imagined that the clouds would carry the message of love to the beloved who is sitting hundreds of miles away. So, this urge to communicate to far away places was there, and either through imagination or through certain practical methods, this has always been happening, and the messages have always been coded. Okay, some kind of energy has been always been utilized, and the messages have been coded and relayed from point to point. Now come back to the early 20th century, to the days of Sherlock Holmes. Now suppose Sherlock Holmes has to send an urgent message to Dr. Watson that the murderer is on the run and he should be nabbed at the next railway station. Now where would Sherlock Holmes go to send this message to Dr. Watson? He would go either to the railway station or to the post office and send a telegram, because in Sherlock Holmes' days there was no telephone also. So the only in England the only method of fast communication was telegram. So he would go to the post office and or the railway station. He would take a telegram form, okay, like this, and he would write down the message. Then the message would be coded, and through the principle of electromagnetism, by pressing a few keys, the message will be transferred to the station required. Alright. So this was in Sherlock Holmes' days, but prior to that, even without the use of electricity, such telegraphic messages were transferred by a method what is known as semaphore, and this was very popular in France. So what happened in France, at the top of the buildings, tall towers were erected, and those towers were fitted with arms. Okay, you know, one platform like this and two arms, which could be moved up and down and in different directions. Okay, and there were exactly 36 positions that were codified, 26 for the 26 alphabets and for the 10 positions for the digits 0 to 9. So 36 positions were codified, and those who knew the code, they knew that okay, if the arms are in this particular position, that means it means this particular alphabet or this particular number. Okay, so these are the 36 positions. As you see, this is a 6 by 6 grid, 6 by 6 matrix. All the 36 positions are shown here. Alright. So those who could decode it, they had to learn this code, and somebody sitting on the ground, he would pull the right pulleys and direct the arms in those required directions, and katak, 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 the arms would move up and down, left and right, and at the far end somebody would see those and somebody would quickly write down the alphabets and decode the message. So this was called the chap telegraph system, and this was the entire France was networked with this chap telegraph system, okay, which did not require any electricity. It was a completely mechanical process. And when Napoleon became the king of France, when he took over, he told this chap telegraph system to send out a message all over Paris that Paris is tranquil and good citizens are happy. So this message by Napoleon was sent out through the chap telegraph system all over Paris and later to all over France also. So this is something like tweeting. Nowadays the politicians would tweet. So but this is in the pre-tweeting era, through the chap telegraph system such messages were sent out. Now it so happened that a person with a very scientific bent of mind, Samuel Morse, he visited Paris, he saw this chap telegraph system, and he was very, very impressed that this is almost in the blink of an eye. In those days that seemed like the blink of an eye, that you can send your message far, far away, and it would work better in England, because in England apparently the visibility is better. So from far away you can see the towers and you can clearly see the positions of the arms of the semaphore. So why don't we start it in England? But then we would like to do it do something which will be faster and which would use the energy of the lightning. So in his own words, he said that where half the time the fogs obscure the skies, but this will not be fast enough, the lightning would serve us better. Okay, so that was his imagination, that we would also devise a system which would take the messages in the blink of an eye, and it would be like a lightning. But how to use the energy of the lightning, or rather electricity, to send messages, that was again subject to various kinds of experimentations. It didn't happen in a day. So it the idea was mooted in Samuel Morse's mind, but then it didn't happen in a day. So all kinds of experimentations were taking place. Say for example, if you take this example of sympathetic needles. If you have two magnetic needles, and if one needle is pointed in one direction, in sympathy the other needle will also be pointed in the same direction. Okay, so the message coded in one needle would be transferred by induction to another needle, but the needles have to be in close vicinity. So this was not really a good enough solution. There was a very eccentric monk, Jean-Antoine Nollet. He was a French monk who lived in a monastery, and he was also a scientist by hobby. So he wanted to conduct an experiment that how fast electricity travels. So what he did is, in his monastery, he gathered 200 monks together, made them stand in a circle. So the circle had a diameter of 1.6 kilometer or about a mile, because all 200 monks were around the circumference of the circle. And then he tied an iron wire around the leg of each monk, okay, and the other end of the iron wire was connected to a Leyden jar. Leyden jar is like a capacitor which stores electricity. By the method of friction you generate electricity and you store a lot of electricity. And then when everybody was ready, he discharged the Leyden jar, and the electricity, the high amount of electricity passed through the iron wire, and the monks got a mild shock. It was not a very major alarming shock, they all got a mild shock. And what the scientists noted is that they got the shock more or less at the same time, which showed that the electricity traveled really fast. Okay, so that was then a proven thing that electricity travels really fast. But then how can one harness this electricity in order to send messages? So all kinds of experimentations, all kinds of ideas, blueprints were put forward. One such idea was, why not use pith balls? Okay, say supposing in a jar you have two pith balls which are representing a certain alphabet, say A, and you connect them with a wire to another pith ball which is far away, say in another room. So if one pith ball deflects, the current will pass, and then the other pith ball in the other room would also deflect. So in principle it works, but it's not a practical, it's not something practical. So even if you have 26 pith balls for the 26 alphabets, it's not easy to send a message through pith balls like this. So Cooke and Wheatstone, they devised a practical, they came up with a practical solution. They had this diamond shaped board on which they had 20 connecting points, 20 nodes, okay, which were 20 letters of the English alphabet. And there were these 5 keys. If we press 2 keys together, then 2 needles would point in a particular direction. And when 2 needles point in a particular direction, one particular alphabet was pointed. So people knew, okay, this is the alphabet. So now the 6 out of these 26 alphabets, the 6 alphabets that got dropped were C, J, Q, U, X and Z. These alphabets were not represented in the Cooke and Wheatstone electric telegraph, okay, because there were only 20 points in the diamond shape box. Alright, so therefore a telegram sent by the Cooke and Wheatstone telegraph would be something like that. A murder has just been committed at Salt Hill, and the suspected murderer was seen to take a first-class ticket to London by the train which left slow at 7:42 p.m. etc. etc. Okay, so instead of J you have G, instead of C you have S, and like that. Okay, so anyway people got used to it and they started deciphering it. But then eventually Samuel Morse, whose imagination was triggered many years back in Paris, eventually he came up with a solution that proved to be very, very handy, very, very user friendly. Okay, and he was assisted in his endeavor by another very good tinkerer, very good technical person called Alfred Vail. The year was 1838. Okay, so this is what in Samuel Morse's vision is, that Morse had a great insight from which all the rest flowed. He saw that a sign could be made from the most minimal event, the closing and opening of a circuit. The electric current flowed and was interrupted, and the interruptions could be organized to create meaning. You know, it takes a visionary to come up with something as simple as this. It was there in front of everybody's eyes, but nobody had that vision to use it. Now, Alfred Vail devised a key which looks like this. This is called a Morse key. You just tap it and the connection is made, and you release it, the connection is released. So, using this Morse key, he made this electromagnetic connection that when you tap a key, current passes through the coil and another key is attracted. As a result, the coil gets magnetized and another key is attracted. That triggers off current in another circuit, the current is relayed till it reaches the destination point. The entire process is the simple principle of electromagnetic induction, that you induce a current into a circuit, it becomes magnetized, something gets attracted, a piece of iron gets attracted, that triggers another process of triggering another circuit, and so on and so forth. Okay. So, this was a simple enough, and if one had to go very long distances, there were relays in between, because in the process of traveling a very long distance the current would get weak. So, there were relays to boost up the current. So, one could really go up miles and miles to take that message. Alright, but the point is, here you are only tapping the key and releasing the key, tapping the key and releasing the key. So, how are you going to codify? How are you going to codify a message through this process? Initially, what Samuel Morse said, that he said, let there be one number or one digit for one alphabet. Say for example 325, 325. So, you tap the key 3 times 3, then you give a break, then tap it 2 times 2, then you again tap it 5 times 5. So, 325 supposing would mean the alphabet A. Okay. So, at the other end also, exactly in the same way, the keys would automatically get tapped because of the process of electromagnetic induction, and somebody would decipher, oh, so it is 325, that means A. But then that was proving to be a very, very cumbersome thing. So, both his assistant and Morse together, they came up with an alternative, which today we know as the Morse code, which is the system of dots and dashes. That means you touch it for a short while, it becomes a dot, and you touch it for a longer time, current passes for a longer period time, it becomes a dash. Okay. So, A is 1 dot 1 dash, B is 1 dash and 3 dots. So, like that, all the letters of the alphabet had their coding in terms of dots and dashes, and also question mark, full stop, comma, explanation mark, the digits from 0 to 9, all of them had their Morse code. Okay. Now, which code to assign to which alphabet? It cannot be completely arbitrary. So, Samuel Morse and Alfred Vail, they went to the printing houses, and the printing houses had these boxes full of the typefaces. Okay. So, they saw that the printing houses on an average had 12,000 E's, 9,000 T's and only 200 Z's. E was the most commonly used vowel and T apparently was the most commonly used consonant. So, therefore, T was promoted to a single dash. If T is used so many times, T should be simple. So, T was a single dash. Okay. So, like that, they use some kind of a system, some kind of a logic to assign the Morse code to every single alphabet, and also the punctuation marks and the digits from 0 to 9. And this was prevalent till the other day. Even 2 years back, we had this telegraph system. 2 years back, formally in India, the telegraph system was closed down. Okay. Till then, this was a very common means of communication, that's sending a telegram. And the first telegram that Samuel Morse himself had sent was this: "What had God wrought?" This was in the year 1844, "What hath God wrought?" So you can try writing it in the Morse code. So once you fill the telegram form, somebody would quickly convert it into Morse code and go on tapping. So the person, the telegrapher who is responsible for sending the telegraph, he is skilled enough to do it really fast. And at the other end, say supposing this is Kolkata, in Delhi when it receives, exactly in that same pace, the dot dash the key would automatically the circuit would get automatically on and off, okay. And the person sitting in the other end would keep an eye and who would quickly write down and decipher it, type it out on the telegram form and send it to the required address to be delivered. In old Hindi films, you might have seen the telegram coming, father seriously ill, come home fast or whatever. In Hindi films, you might have seen that. There used to be a pink slip where the telegram was pasted, telegraphic message was pasted. Now, there was an expense attached to it. So, typically it was 50 cents for 10 words. Alright. So, the question is, who were the takers? So, this system was in place. Who were the takers? The first takers were the fire brigades and police station to send urgent messages. The next takers were the proud shopkeepers, that you can send a telegraphic requirement from your home and we will deliver it to your house. Okay? And then simple weather reports also started crisscrossing the wire. That today in Glasgow the weather is good, it's bright and sunny. In Lancaster, suppose it is snowing. Okay, so like that. The weather reports also started crisscrossing. But the most prolific users of the telegraph system were the newspapers. And it's easy to guess why. Now, the sale of a newspaper would go up if it could give something more than local news, okay? And the telegraph system allowed him to do that. So, the most prolific users of the telegraph system were the newspapers. That's why so many newspapers are today called Telegraph. In Calcutta, we have the Telegraph. In England, we have the Daily Telegraph. Okay, so newspapers are called Telegraph because they become very, very dependent on the telegraph system. And these were the signals used to go through wires. So, these cables were laid all over the country. So, 40 miles only in 1846, it jumped to 12,000 miles in 1850 and 23,000 miles in 1852. It jumped to that. And then transatlantic telegraph cables were also laid on the bed of the Atlantic Ocean, which connected England to America. Okay. So, those were also laid. And very soon, except for Antarctica and the Arctic belt, all the countries were crisscrossed with telegrams. Okay, and it was a common sight that telegraph cables are being laid either on the land routes or even below the river beds. I mean, on river beds or on sea beds. It was a common sight, and the entire globe got kind of enmeshed with telegrams. Okay, rather telegraphic cables. Entire globe got enmeshed with telegraphic cables, and that was the first era of globalization. The first transatlantic communication occurred on August 16, 1868. So, therefore, communication which took about 10 days to cross the Atlantic Ocean, now it took just about a minute. And that was the beginning of a new era. It was the beginning of a globalized, networked world, and it was the beginning of a new thinking process, because telegraph opened up the imagination of the people, that one could know for sure, convincingly, what is happening several miles away without taking recourse to imagination, thanks to the telegram. Okay. So, that changed the mindset of the people. Just as now we are in a kind of safety net, we know that with the GPS system we will not get lost and we can track down our friends and relatives wherever they are. So, similarly, a kind of safety net got made, and people knew that, okay, so what is happening several miles away, that also we can come to know. So it was a different kind of thinking process that was initiated, a different kind of life, a different kind of outlook to life that was initiated through the popularization of the telegraph system, which was initiated by Samuel Morse. Okay? But more is yet to come, which we will see in the next episode, where the world went after it got crisscrossed and enmeshed in a mesh of telegraphic cables. So, that is left to the next episode. Thank you so much. I hope you have enjoyed this talk. See you soon. Thank you very much.